All right, guys, this is Mr. H. This is question number 29 from the August 2024 Regents exam. It's a quadratic equation, and they want you to use the quadratic formula to determine it. And here's the key word that you need to pay attention to. It says, I need the exact roots. What that means is you cannot give me decimals. I want the root left as a fraction. So no decimals, only fractions. So let's go. So I put this on the graphical organizer just to show you a couple things. So here's the equation, x squared plus 3x minus 6. We know that the a value is 1, the b value is 3, the c value is a -6, and that's what we're going to plug in. Now, you need to do this part in order to get full credit. You gotta show the graders that you know how to use the quadratic formula. So we're going to put 3 in here, 3 in here. A value is 1. The C value is a -6. The A value is 1, right? Now, the key to this question is whatever the B squared minus 4AC is, we got to leave it. If it's a radical, we got to try to simplify it, but we got to leave the radical as a radical, because if we don't, we're going to get decimals, and we can't use decimals for this. So what we're going to do is, at this point, we're going to take the calculator and we're going to store 1 into A, 3 into B, a -6 into C, and we're going to calculate what the B squared minus 4AC is. So we're going to come here. Let's do it. 1, control store. We're going to put it into A. Boom. We're going to do, what's the other one? 3. We're going to store that into B right here. And then we're going to do a -6, and we're going to store that into C. And boom, there you go. Now, we're going to do B squared minus 4 times A times C, and then press enter. So that is that's the part that goes inside the square root. Now, I'm going to do something. I'm going to show you something. It's, I call this the LeBron key. Menu 23. Menu 23 is the factor key. So if this number can be factored, it will. And you can see the factors are 3 and 11. But neither one of these are perfect squares. So that means we can't do anything with these numbers. We can't simplify the radical. We just leave it as 33. So let me go and finish this up using, so that means that this is going to be the square root of 33. So if we were to write this, our answer is going to be x equals a -3 plus or minus. This part is going to be 33. We can't simplify it. There's nothing we can do. There's nothing else we can do. So you just leave it as square root of 33, and on the bottom is going to be 2. This is 2 points. I've plugged in, I've showed the test makers that I know how to use a formula, and then I left it as a fraction. That's why I get both points. That's what you're doing here. So for this one, that's all you need to do. Now, if for some reason you didn't realize that you needed to leave it as a fraction, you could have done, and if you did this, let's do control divide, and you did a -b plus, we don't have a plus or minus key, so we're just going to do plus or minus the square root, and then we're going to use the formula b squared minus 4 times a times c, and then on the bottom it's going to be 2a, and then boom. That's the decimal. That's the decimal equivalent of the first root. So if we did a -3 plus the square root of 3 divided the square root of 33 divided by 2, we would get this, right? This is not what they wanted. But if you put these two roots, let me show you the second root. If I copy this, and then if I go in here and make this a minus, that's the second root, right? I got both of them, but they're as decimals. They didn't want them as decimals. They said they wanted the exact root. So that means you have to leave it as a fraction, everything. All right, so, but if you did this, you should have gotten some points for it. Like, this is a 2-point question. If you did this and you rounded it, I think they would give you a point for that. So even if you don't know exactly what to do or don't know the exact root or what that means, just go ahead and solve it the best way you know how. And you can still get points for that. So, all right, I'm going to stop and I'm going to post this.